Good morning, Phoenix class, and welcome to your maths lesson for today. I can find the area of a triangle. So what have we done so far? We've had 2 lessons on this already. So we found the area by counting squares. We've also found the area by chopping our isosceles triangle in half and making a rectangle. And then yesterday we learnt that 2 right-angled triangles make a rectangle, 2 identical right-angled triangles. So therefore we can do the length times the width and divide that by 2. So our first question today, what is the area of the triangle on Lexi's slide? So let's have a look. Hers is the red and the yellow one. So first of all, we've got to think about what is the length or the base of the triangle. So we can see that here is 14 centimetres. If it was a rectangle, we'd call it the length, wouldn't we? I'm calling it at the base because that's the way it stands up. Doesn't really matter. Then we've got to think, how tall is the triangle? Well, if we draw a perpendicular line, now a perpendicular line is a line that ends at a right angle to a different line. So there we go. You can see the line between the red and the yellow. That is perpendicular to our base. That means it meets the baseline at a right angle. So that perpendicular line goes from the very tallest point in the triangle down to the base. And we call this the perpendicular height, or the height for short. So how are we going to find the area of this triangle? We are going to do base times height, and then because it's half a rectangle, we're going to divide that by 2. So in this case, what's our base? Our base is 14, our height is 6, so times those together, that will give us 84, and then divide that by 2, and we'll end up with 42 centimetres squared. We can see on this one again. So if you look at our triangle, you can see that we can make our big triangle, we can split it in half, the red one and the yellow one. And if we made a rectangle out of the red one, we would have 2 identical triangles. So that same formula that you found yesterday, base times height divided by 2, still works, doesn't it? Because both of those triangles are identical, they're equal in size, and they make a rectangle. What about the yellow one? Does that apply there as well? It does, doesn't it? So both of those are the equal size. So we can still use our formula, base times height divided by 2. Now, we could count the squares, so we could measure and split the triangle in 2. But actually, we don't need to do that. If we just take the base of the total triangle, like I did on the previous page, as 14, and then we take the highest point on that triangle in a perpendicular line from the base, well, that's 6. And then we can find out for the whole triangle, rather than doing it in 2 parts. So let's have a look at the area of Mohs sine. So we have the base times the height divided by 2. So what's our base? Our base is 40. So our height, therefore, must be 30. We times those together. So 4 times 3 is 12. Times by 10 times by 10. That's going to give me 1200. And again, I'm now going to divide that by 2 because it is half a rectangle. 1200 divided by 2 gives me 600 centimetres squared. And here we've got going through that again. Now I've gone backwards there, haven't I? Let's go and the next slide. Right, now this triangle is a bit odd looking. What is our base? Well, our base is the 6 centimetres. It's the height that causes a bit of a trouble, isn't it? So I want you to have a look. What is the highest point away from the base of the triangle? It's there. So if you were standing on that highest point and you dropped a ball of string down, it would fall straight down, wouldn't it? And it would reach an area level with the base, and it would be there at right angles. It would be perpendicular. So actually 5 is our height, our perpendicular height, as we can see there. B asks you to draw a measure. If that's too difficult, you can leave that one out. Then on to the practice book. So in A, we're looking for the base times the height divided by 2. So you've got the base is 6, your height is 5. You're going to divide that by 2. B, have a think about what the base is in B. Yep, the base is 1.5 and the height is 6. Times those together and divide by 2. In C, oh, this is really sneaky. They've turned the triangle upside down. So where's the base? Well, the base is here, but we know what the base is because it tells us at the point, doesn't it? That width is 4. Our height is 17. So 4 times 17 divided by 2. Now, number 2, draw 3 triangles with a base of 4 centimetres and an area of 8 centimetres. What do the triangles have in common? Well, you could try this as trial and error to see what you can come up with, or we can use a formula. So we could say that the area, let's put it as A to save me writing it out, equals base times height divided by 2. So if we had put our numbers in that we know, we could say that 8 equals 4 times the height divided by 2. All I've done there is replaced the area that we already know and the base that we already know. Now we're going to use a bit of an inverse and start working backwards. So if we would normally divide the base by height by 2, then what we want to do to get the area, what we want to do if we're working backwards, the inverse to divide is times. So if we do 8 times 2, that will give us the answer of 4 times the height. 8 times 2 is 16. So 4 times the height equals 16. So what's h going to be? It could be 16 divided by 4. Have a go at that. In question 3, Ben thinks the area of this triangle is 24 centimetres squared. What has Ben done wrong? What is the area of the triangle? Well, the first thing you've got to do is work out what the area of the triangle is. So we want base times height divided by 2. And in this case, your base is 8, your height is 3. You can complete the rest of that on your own. In B, Alex thinks that the area of this triangle is 60 centimetres squared. Is Alex correct? Well, what's your base in this one? Doesn't really look like a base because it's actually on the side, isn't it? They've just turned it round. But I know that 12 is the base because my perpendicular line meets it at a right angle. So my base is 12, my height is 8. Is Alex right? Can you explain why? Question 4, A, find the area of the triangle. Base times height divided by 2. And the same goes for 4B. And finally, question 5. Now, I'm asking you to remember what you did several days ago with the parallelogram. Can you remember what the formula was for finding the area of a parallelogram? Area of a parallelogram is base times height. That should help you have a go at this question. If you feel you need more practice, there are some questions there. If you still don't understand after you've watched this video, you can also go to BBC Bitesize because they've got a lesson on exactly this. So you can have a look at that as well and see if that helped you. There are some challenges there for you to have a go at. And then, of course, you're going to finish the lesson with a reflection, just explaining how you find the area of a triangle. Good luck today and have fun. Bye.